This is class 36 of my arithmetic course. Today we're going to learn about competitive tests. The tests that you take in this course, and most of the tests that you take in school, are not what I would consider competitive tests, because those tests are simply designed to figure out what you know. They're not designed to tire you out or to put a lot of pressure on you or to trick you. They're simply designed to figure out what you've learned in your course. Whereas competitive tests are designed to figure out how well you compete against other students. So the tests are much, much different. So the purpose for this class is to get you psychologically prepared for competitive tests, because the way that you approach those tests and the way that you perform on those tests is going to be much different from the way that you perform on the tests in this course and on the tests in school, if you're attending a school. So let's first talk about what competitive tests are and why you might take them. These are some examples of competitive tests. These are high school entrance exams, and these are college entrance exams. Just some examples there. And what that means is these are exams that high schools and colleges use to determine how well you take tests so that they can determine which students are better when it comes to simply scoring well on multiple choice tests. And we're going to talk about what multiple choice means as we go along. Now, there's a good chance that you are not going to need to worry about these types of tests for a while, but even if you don't take a competitive test, you may take a multiple choice test. In that case, the principles that we're going to learn today are going to apply. I also want to mention that we're not going to learn everything there is to know about competitive tests. We're just going to do a brief introduction, because the purpose of this course is not to teach you about competitive tests. You can spend years just learning about competitive tests and improving your skills. We're just going to talk about the basics today. So again, the purpose of this class is to give you instruction and to psychologically prepare you for competitive tests, so that if you do have to take a competitive test, which are almost always multiple choice tests, then you won't be caught off guard. So let's talk about the difference between what I call in-class tests, the tests that you've taken in my course, and competitive tests. Also, I forgot to mention that sometimes these tests are used to figure out what math course you should be placed in. Now, I don't believe that they should be used for that purpose, because they don't do a very good job of that. But that is another reason that they're given. All right. So in-class tests, like I mentioned, are provided by your teacher, whereas competitive tests are provided by a third party, a business that is designs tests and is paid to design tests. In-class tests, like I mentioned, are designed to figure out what you know, whereas competitive tests are designed to figure out how well you compete against other students. So they're much, much different in the way that they're designed. In-class tests are usually not multiple choice unless your teacher is using problems that were from a competitive test. Whereas competitive tests, they always or almost always use multiple choice questions, because it makes it easier for them to grade the test. In-class tests are not a race. You're usually given plenty of time to finish the test, whereas with competitive tests, you're always racing against the clock. In these tests that I mentioned, you usually have less than 1 minute to do each problem. And so it's extremely difficult just to read the problem and answer the problem in the time that you have. In-class tests, for example, in my test, you always have to show your work. You have to show that you can not only read mathematics, but you also have to write mathematics. Whereas competitive tests, you don't have to show your work. They don't care what you write, as long as you mark the correct answer, as long as you choose either A, B, C, D, or E. In-class tests, there shouldn't be problems that you don't recognize. Again, in-class tests are not designed to trick you. As long as you study for the test, you should know everything on the test. Whereas with competitive tests, there will always be problems that you don't recognize, because, like I said, there are people that are paid to write new tests every day. and new problems. In-class tests are not designed to tire you out, but competitive tests are designed to tire you out. Competitive tests are usually, if you're taking a high school entrance exam, it's going to be between 2 and 3 hours, and if you're taking a college entrance exam, it's going to be over 3 hours. And the test designers design the test that way on purpose because they know that the average student can only concentrate or can only read those types of problems for maybe an hour and a half to 2 hours, and then most students really cannot concentrate after that. So they design the test longer than 2 hours on purpose because they want to spread out the scores. They want to see if there are any outliers. Remember, we discussed the term outliers in our basic statistics class. An outlier is an unusual data point, and somebody that can concentrate for more than 2 hours is unusual, so they want to see which students are really good at taking these tests. So the tests are very, very long, and you're going to be tired. It doesn't matter how you could be the best test taker in the world, but it's going to take a lot of energy just for you to get through the test. And that brings me to the next point. In-class tests are not, they don't always require a great deal of effort and energy to make it through the test, whereas competitive tests, they always require a huge amount of effort and energy. It doesn't matter how well you take tests. You could be the best test taker in the world, but it's still going to take a lot of energy simply to read all those problems in the time allowed, or all the questions. And so those are the differences between in-class tests and competitive tests, but there is one thing that is the same for both these types of tests, and that is practice is the only way to improve your score. So those are the differences between the competitive tests and in-class tests, and the similarities. So that said, let's go ahead and get started. And also, I want to mention that these tests usually only test your ability in math and English, so that they don't usually test other things. Those are the primary subjects. All right. So that said, now let's go to our first problem. Now these are multiple choice problems. You can see you have 5 choices, A, B, C, D, E. And you have to choose which one is the correct answer. So that's what we're going to be studying today, multiple choice questions. You have to choose A, B, C, D, or E. So because these are multiple choice questions, the approach that we're going to take to figure out which is the correct answer is going to be different from the approach that you use on the tests in this course. So let's go ahead and read the problem. And notice here that we have 3 versions of the same problem. It's the same problem for all 3 of these, but the difference is the possible answers that are given. Notice that these answers here are very far apart from each other. We have 100 and we have 13. But the numbers over here, they're very close to each other. They're almost exactly the same. And the numbers here are pretty close too. So the approach for each one of these problems is going to be much different because of the answers that are given. So with this version, we're going to use something called we're going to round off and we're going to estimate. So first of all, how do we find the area of a rectangle? Well, if you recall, we multiply the width times the length. But because these possible answers, again, our answer is one of these. It's going to be either 100.003 or it's going to be 21.003 or 20.003. Our answer is going to be there somewhere. But because these numbers are so far from each other, so far apart, what we can do is, like I said, we're going to round off and estimate. So we're going to round this number to 9, and we're going to round this number to 4. So we're rounding both those numbers to the nearest whole number. So now, to find the area of a rectangle, we multiply the length and width. So this number is rounded to 9, and the other number is rounded to 4, and we multiply, and we get 36. So 36 is our estimate. So our answer has to be 36, or somewhere around 36. And you can see that this number is nowhere near 36, so it can't possibly be that number. And this number is nowhere near 36, so it can't be that number. You know what, I'm going to go ahead and highlight those instead of marking them out. So it can't be those two, and then 21 and 20, it can't really be those, so the only answer it could be is D. So that was an estimation method, and I want you to write the method that you use, and we can abbreviate with E for estimation. That was an estimation problem. Now, if you were to actually perform the algorithm, we would have to set up the numbers, and this is the algorithm that you learned in the class on multiplying decimals. Then you'd multiply using the methods that we learned. Make sure to line up all the numbers. And you'd get 38.003. Now that took me about 20 seconds or 30 seconds to do that. But if I'd used the estimation method, by rounding these numbers off and then multiplying, I would have found the answer in about 5 seconds. All right, so if I use the algorithm, it takes me about 20 to 30 seconds. But if I use estimation, it takes me 5 seconds. So if you were given these possible answers to this problem, and you actually used the algorithm, you would have wasted between 15 and 25 seconds on this problem. Now, I know what you're thinking. You're thinking, well, so what? Why can't I just use the algorithm? Well, the reason you can't use the algorithm is because this problem is designed by the test makers to be a 5-second problem. So if you take 20 seconds or 30 seconds, then that's time that is going to be taken away from other problems that are much more difficult and require much more time, so you're not going to be able to finish the test. That's the important point. So to demonstrate further, let's go on to 1B. So now we have much different answers. Or excuse me, they're much different from the previous problem, because these answers are almost all exactly the same. They're just about a thousandth of a square inch off. So we can't estimate with this problem because the numbers are too close. So we have to perform the algorithm. But notice when we perform the algorithm, we get 3, and then the next number down we know is going to be 0 because we always have to have a placeholder. So what that means is when we multiply 7 and 9 to get 3, that number is going to be the actual number farthest to the right in our final answer. So the number farthest to the right has to be 3, but you can see that there's only one possible answer where 3 is the number farthest to the right. So D has to be our answer. So we can eliminate all these other answers, and D has to be our answer. All right, so the important point is we didn't have to do the entire algorithm. All we had to do is multiply 7 times 9, and that gave us the answer because that gave us 3. So that's what I call an algorithmic shortcut, and that problem should have only taken us about 5 seconds. Both these problems take about 5 seconds each. 5 seconds to actually do the computations. It might take you a couple seconds just to read that particular problem. So a total of maybe 7 or 8 seconds to answer that problem. So you did have to use the algorithm, but you used a shortcut in the algorithm. Again, these problems should take you only about 6 or 7 seconds total. So Now let's go on to 1C. Now 1C, unlike these first two problems, that problem is going to require us to do the entire algorithm. Because if we do, these numbers are really close together, and if we do the algorithm, we're going to get 3. That's the first number we're going to get, but all these answers have 3. And then we're going to get 2 zeros, but all of these answers have 2 zeros. And then we're going to get 8, but 2 of these answers have 8, so we have to do the entire algorithm to get 38.003 and finally isolate our answer. So we can eliminate these answers as we go along, and finally our answer is 38.003. So that's a problem that required us to use the entire algorithm, so we're going to write A for algorithm. So with these types of problems, I want you to write E for estimation, or AS for algorithmic shortcut. That's when you can use the algorithm and with a shortcut, or A if you're using the full algorithm or most of the algorithm. So again, what is the point of all this? Why are we doing this? Well, the point is this problem would take about 20 or 30 seconds, as we explained, whereas these problems would only take 5 seconds. So if you're given 5 problems that take 5 seconds each, and then you're given 5 problems that take let's say 15 problems that take 1 minute each, then that means that and you're only given a certain amount of time. So we have 20 problems total in this math section, say. Because these problems are difficult, you'll need the full 15 minutes for these problems. And so if you take more than 5 seconds for these first problems, you won't have enough time to finish these other problems. So the test makers design the problems that way on purpose. And so if a problem only takes 5 seconds, then you better get it done in 5 seconds, because you're going to have no chance to finish the more difficult problems. There may be problems that take 2 minutes or even 3 minutes for you to answer. You have to finish the easy ones as quickly as possible before you get to those other problems. So those are the types of problems that we're going to do. Let's do a couple more of those together so you can see the point, and then you can try some on your own. All right, if Karen bought a watch for $17.62, a necklace for $36.69, and a computer for $499.76, how much did she spend in total? So we're going to look for the problem where estimation is going to be our method, and it looks like these numbers are almost all the same, and these numbers are almost all the same, very close together, but these numbers are quite different. So 2A is probably going to be the estimation problem. So what we're going to do is we're going to round this off to 20, round this off to 40, and round this off to 500. And we're going to add all those numbers up because we want to find the total cost. So 400 plus 20 plus 40 is going to be, whoops, that should be 500, sorry. It's going to be 560, so our answer should be around 560. And the round-off error here is about 3 approximately, and the round-off error here is about 2. So our answer should be no more than about $5 from our estimate. So our answer has to be E, because these other answers are just nowhere near what we need. So E is the correct answer. So that was an estimation problem, and I want you to write capital E for estimation. Now for the next problems, the next version of this type of problem, we have, like I said, all these numbers look very close together, so we're going to have to do the algorithm. So we're going to set this up, 499.76, 36.69, 17.62, and we have to line up the decimal. Remember, when you add decimals, you have to line up the decimal or else you'll get the wrong answer. So we're going to go ahead and add these, And look, we got a 7. The number farthest to the right must be 7. So I see over here, I can see the answer must be E. I don't have to keep going, so I had a shortcut on that version of the problem, so I can write algorithmic shortcut. Whereas in this problem, I have to keep going because they all have 7s. And so I'm going to carry, and we have 20, so we have another 0. So they all have, the answers all have 0, so we have to keep going. And 24, but they all have 4, so I have to keep going. And then 15, and at that point we can stop because we have the 5 there. But if we carry and keep going, obviously we get 554 and then bring the decimal straight down. So that problem required us to do most of the algorithm. So that's a problem testing your ability to do an algorithm. So again, these problems all look the same. They look like they're testing the same thing, but they're not testing the same thing. This problem is testing your ability to estimate, whereas this problem is testing your ability to do almost the full algorithm, and this problem is testing your ability to see a shortcut in the algorithm. So even though these problems look like they're testing the same thing, they're really not. They're testing your very, very different skills. All right, so let's do 3A. And this will be the last one we'll do together, and then you can try some on your own. What is the average of the following 3 fractions? So let's look for the problem where we estimate first. So it looks like this is going to be the estimation problem because the answers are so far apart from each other. So we're going to use estimation on 3C. And in order to do estimation, we're going to change 1/2 to 4/8 by using the fundamental principle of fractions. We're going to multiply both sides of this fraction by 4 to get 4/8. So we get 4/8, and I'm going to order from least to greatest. So we have 4/8, 5/8, and 7/8. And average is another word for the mean. Remember, we learned the mean. Mean and average, they're measures of the center of the data. So the center should be somewhere around 5/8. But 2 is bigger than 7/8. So that can't be a measure of the center. So we can eliminate that one. And 1 1/8, that's also bigger than 7/8, so it can't be that one. 0.02 is much, much smaller than 1/2. That's 2 1/100ths. So that can't be the answer. And 0.2 is 2/10ths, which is much smaller than 1/2. So our answer has to be 2/3. That's a problem that we could figure out in about 5 seconds. So that is an estimation problem. We didn't have to do any kind of algorithm, any kind of computations. We just had to know that the average is a measure of the center of the data, and we could estimate the average. So now let's go to these other problems. We're going to have to use the algorithm for average to figure out which is the possible answer because the numbers are very, very close to each other. So the algorithm for finding the average of numbers is you have to add up all the numbers and then divide by how many numbers there are. And there are 1, 2, 3 numbers. So we're going to add them all up and then divide by 3. So to add them, we have to get a common denominator. So we already did that for 1/2. So now we just have to add them up, and we get 16/8. And now we have to use the, we have a whole number, so we're going to have to write 3/1. And you can review the class on dividing fractions if you want, but what we do is we change the division sign to multiplication, and we flip the divisor, and then we multiply straight across. So 16 times 1 is 16. 8 times 3 is 24. And if we use the fundamental principle of fractions, and we divide both those numbers by 8, 16 divided by 8 is 2, and 24 divided by 8 is 3. So we have 2/3. So you can see that that gives us the answer for version 3B. So we had to do the full algorithm for that problem. Now in this problem, we have to keep going even further, because in this problem they give us the decimal form. So we have to change this fraction to a decimal. So to change a fraction to a decimal, you take the numerator and divide by the denominator. And we got 6, but we can stop there because the only answer that has 6 as the first number is D. So the answer must be 0.6 bar. We can eliminate all the other answers. So that was, even though that problem took longer than this problem, it was still a problem that required us to use a shortcut. So we can say algorithmic shortcut on that problem. So AS. All right. So again, all we're doing is figuring out how to approach these problems. We want to figure out if it's a 5-second problem or if it's a problem that requires more time. Sorry, that I don't know why it's bouncing back and forth like that. So now you attempt problem 5A. Actually, what am I doing? I skipped a problem. I'm sorry. You attempt problem number 4, and you're going to write AS for algorithmic shortcut, A for algorithm, or E for estimation. So you have to figure out which one it is. So go ahead and attempt problem 4, which you have to convert a fraction to a percent. So remember, to convert a fraction to a percent, you take the fraction and convert it to a decimal by using long division, and then you move the decimal 2 places to the right and add a percent sign. So go ahead and attempt number 4, and when you come back, we'll do it together. Pause the video. All right, we're back. So let's find the estimation problem. This is going to be the estimation problem because those answers are so far apart from each other. 99.987%, that's almost one whole, because percent means out of 100. So 100% is 100 out of 100, which is one whole. So 99.987%, that's almost one whole. So one whole cannot be equal to 3/7. So we can eliminate B. We can also eliminate C, because that's even bigger than 99%. And we can eliminate 3.73 bar percent, because that's about 4 out of 100, which is much smaller than 3 out of 7. Think about it. If you're cutting a pizza into 100 parts and you have only 4 of those parts, those pieces are going to be very small. But if you cut a pizza into 7 parts and you take 3 of those parts, that's going to be much bigger. So we can eliminate E, and we can also eliminate D, because 3/7 is less than 1/2. If you take 7 and divide by 2, you're going to get 3.5. So 3.5 is half of 7. So what that means is that 3.5 out of 7 would be 1/2, but we don't have 3.5, we have 3. So 3 out of 7 has to be less than 1/2, so it can't be 73.73%. So our answer has to be A. So that was an estimation problem. So if you write E, if you wrote E for 4B, good job. All right, so now let's go to this problem here. We're now going to have to use the algorithm. So I'll go to the margin for that. So you divide the numerator by the denominator. Looks like it goes in 4 times. And you can see all of our answers have 4 here, and all of our answers have 4 all the way over here. So we don't know what the answer is yet. But then we bring down a 0, and 7 goes into 22 times, and now we see that this must be our answer. So we can eliminate all these other ones. And, whoops. We can eliminate all these, and this must be our answer. So that was an algorithmic shortcut. If you wrote AS for that one, good job. And this problem, as you can probably figure out, that problem is going to be the actual full algorithm, because these numbers are all the same until you get to the very last number. So that problem is testing your ability to do the full algorithm. So if you got AS for 4A, E for 4B, and A for 4C, good job. All right, so now let's try another one. Let's try 5A, and go ahead and attempt that problem, and when you're done, we'll do it together. Pause the video. All right, we're back. So first we're going to find the estimation problem, which looks like it's going to be this problem down here because those numbers are so far apart. And if you realize that we have to subtract the numbers, that's correct. So we're going to round this number to 800, and we're going to round this number to 600. And if you subtract 800 minus 600, 800 minus 600, you get 200. So our estimate will be 200. So this answer is nowhere near 200. This answer is nowhere near 200. This answer is nowhere near, and this answer is really not very close either. So it looks like this is going to be our answer. And we rounded down. We subtracted 46 to round down, and we subtracted, or we actually added, I think, 37 to round up here. So our answer can only be about 100 off, so it's got to be 283 miles. So that's a problem that requires estimation. If you said estimation, good job. All right, so the other problems, we're going to have to use the actual algorithm. So 846 minus 563, and we subtract, and look what happens. We have the answer here immediately. So that was an algorithmic shortcut problem. But over here, these are all 3s, so we're going to have to keep going. And borrow from the 8, give to the 4. We have 8, but we still have 2 problems with 8, so we have to keep going. And we finally get 2. So that was a problem that required us to do the entire algorithm. So if you got A for 5A, AS for 5B, and E for 5C, good job. All right, so why don't you try number 6, and when you come back, we'll do it together. Pause the video. All right, we're back. So it's difficult to see what we're supposed to do on this type of problem. So what we're going to do is we're going to take this number, 422.4, and we're going to make it a smaller number. Let's say that that's 24 miles instead of 422.4 miles. And this number we'll just keep as 8 miles every 1 day. So think about this problem. The person rode 24 miles total, and his speed was 8 miles every 1 day. So how many days was he riding his bicycle? So 24 miles total, and he rode 8 miles per day. So how many days did it take him to move 24 miles? Well, if you said three days, you were correct. But here's the big question. How did you figure out 3 days? Did you multiply these numbers? 8 times 24? I don't think so. That wouldn't give you 3. Did you add these numbers? Nope. That didn't give you 3. Did you subtract these numbers? Nope. That didn't give you 3. The only way to get 3 is to take these numbers and divide 24 by 8. So we have to take this number and we have to divide by 8. So again, that's how we figure out how to do the, or what operation to use. So we have to figure out how many times 8 goes into 422.4. But these answers over here, you can see, are pretty far apart from each other. If 8 goes in 522.8 times, then let's see how many that would be. Let's estimate. Let's round this off to 500 and multiply 8 times 500. You get 4,000. So 4,000 is nowhere near 422.4, so that's not a possible answer. 1.8, 8 goes in a lot more times than 1.8, so again, we can eliminate that one. 100 times, that would be 8 times 100 is 800. We don't want 800. And again, we're using multiplication, which is the opposite of division, to estimate what the answer would be. And 10, if you multiply 8 times 10, you get 80. So 80 is nowhere near 422.4, so our answer has to be 52.8. So there are some computations involved, but you don't have to do the full algorithm. It's really an estimation problem. You round off and you estimate. So if you wrote E for 6C, good job. That's an estimation problem. All right, so now we have to do the actual algorithm for the rest of the problems because they're too close together. 8 goes in 5 times, 40, bring down the 2. But at that point we can stop and we know that this must be the answer because it's the only answer that has a 5. So that was an algorithmic shortcut problem. We have to keep going for the next problem. Bring the decimal straight up and we had to do the entire algorithm. So that wasn't a problem that required the entire algorithm because they all had 5s and they all had 2s, so we had to find all 3 of those numbers. All right, so if you got A for 6A, AS for 6B, and E for 6C, good job. So again, the purpose of those problems was just to test your ability to estimate or to use a shortcut or to use the algorithms. So again, these problems, they look they look like they're exactly the same problem, but really they're testing your ability to do very different things. And if you don't finish the estimation problem and the shortcut problem as quickly as possible, you're guaranteed to not have enough time to finish the test. So doing these tests is very, very different from performing on the tests that you would take in school or in my course. So again, we're psychologically preparing you for what you'd encounter if you take these types of tests, the competitive multiple choice tests. All right, so now we're going to learn something called the plug-in method. Because these are multiple choice questions, one of these answers has to be correct. So let's do number 7. Find the missing number in the following equation. We know that one of these answers, if we plug it into this equation, it's going to make the equation true. Now, you don't know in order to solve this problem without using these numbers, you would have to use algebra, but we haven't learned algebra yet. So we cannot solve this problem. It looks too difficult. What this problem is asking is, what number do you plug into this question mark so that it makes the equation true? But, what this means is 4 times 5 divided by what number, and then raised to the second power plus 1 is equal to 5. So it seems too difficult. It seems that we cannot do it because we don't have the algebra skills to solve this problem. But because this is a multiple choice problem, and because we have one of these numbers is the answer, we can use what's called the plug-in method. So what we're going to do is we're going to plug in 2 and see if the equation works. So 4 times, we have to use PEMDAS, so parentheses first. Then we have multiplication and division, so we're going to have to move left to right inside there. So 4 times 5 is 20. And then 20 divided by 2 is 10. 10 to the second power is 100. And then 100 plus 1 is 101, which is not equal to 5. So it cannot be A. So I know what you're thinking. You're thinking this method is going to take a long time, but you don't have to write it all out. Again, the makers of the test don't care if you show your work. You can do it in your head. So now let's plug in 5. So we eliminated that answer. Let's plug in 5. So 4 times 5 is 20. 20 divided by 5 is 4. 4 to the second power is 4 times 4, which is 16. 16 plus 1 is 17, which is not 5. So it cannot be 5. Let's plug in 4. 4 times 5 is 20. 20 divided by 4 is 5. 5 to the second power is 5 times 5, which is 25. 25 plus 1 is 26, so it cannot be 4. Let's plug in 10. 4 times 5 is 20. 20 divided by 10 is 2. 2 to the second power is 2 times 2, which is 4. 4 plus 1 is 5. So that works. So our answer has to be D. So again, it looked like we could not solve this problem, but when we use the plug-in method, we could figure out what the answer had to be. So now you try a problem, or that type of problem. For number 8, and when you come back, we'll do it together. All right, we're back. So let's plug in 12. First of all, we're going to do the 1 plus 1 squared. So 1 plus 1 is 2. 2 to the second power is 4. 4 times 12 is not one of your multiplication facts, but that's going to be 48. And 48 minus 8 is 40, which is not equal to 12. So we can eliminate that as one of the possible answers. Now let's plug in 5. So 1 plus 1 is 2. 2 to the second power is 4. 4 times 5 is 20. 20 minus 8 is 12. So I'm going to go ahead and plug that in just so you can see what I did there. So 5 is z. And we got 2 squared. And 2 to the second power is 2 times 2, which is 4. And we got 20 minus 8, which is 12, equals 12. So the answer was B. We got lucky because it was only the second one. So if you got B, good job. Z has to be B. So this is the plug-in method. We're taking the possible answers and we're plugging them in to see which one makes the equation true. This is a very effective method when you're using multiple choice or you're doing multiple choice problems. So now let's try number 9. 18 divided by a number decreased by 1 is equal to 0. What is the number? So this looks really confusing. But again, if we use the plug-in method, we'll see that it's really not that difficult. 18 divided by a number, which I'll just write as n because we don't know what it is, decreased by 1 is equal to 0. So it looks like this, again, this is an algebra problem, but we don't know algebra. We haven't learned algebra yet. But if we plug in the possible answers, let's plug in 6 first. 18 divided by 6 minus 1. 18 divided by 6 is 3. 3 minus 1 is 2. 2 is not equal to 0, so it can't be that it can't be A. So then let's do the rest on our head. 18 divided by, so let's erase this. 18 divided by 3 is 6. 6 minus 1 is 5. That doesn't work. 18 divided by 9 is 2. 2 minus 1 is 1, which is not equal to 0. And let's plug in 2. 18 divided by 2 is 9. 9 minus 1 is 8. That's not a possible answer. So we can eliminate all these. So the last answer has to be correct. E. 18 divided by 18 is 1. 1 minus 1 is 0. So again, that was a plug-in problem. So now you try number 10. It's the same type of problem, and when you come back, we'll do it together. Pause the video. All right, we're back. 5 times a number increased by 7 is equal to 32. Let's plug in 3. 5 times 3 is 15. 15 plus 7 is 22. That doesn't work. So now let's try B. Plug in 2. 5 times 2 is 10. 10 plus 7 is 17. That doesn't work. 17 is not equal to 32. Now let's try C. Plug in 5. 5 times 5 is 25. 25 plus 7 is 32. 32 is equal to 32, so C must be the answer. Again, we use the plug-in method. So if you got C, good job. All right, so now we're going to go to some slightly more difficult problems. The volume of a rectangular prism is equal to the volume of a cube. And again, the plug-in method is used when it looks like the problem is impossible to solve. So this is going to be one of those types of problems. The volume of a rectangular prism is equal to the volume of a cube. The side length of the cube is twice the width of the rectangular prism. If the height and length of the rectangular prism are 8 feet and 4 feet respectively, meaning the height is 8 feet and the length is 4 feet, because it's in that same order, what is the side length of the cube? So I know what you're thinking. You're thinking this is impossible. I can't do this. This is way above my level of math, but that's not true. You can do this problem because we're going to use the plug-in method. So first we have to know the volume of a rectangular prism. let me draw this real quick here. So a rectangular prism would look something like this, and then a cube would look like the same thing, but all the sides would be the same same length. So we have width, we have length, and we have height, and we'll just call all the sides S for the cube. I'm going to move this down a little bit. So those are the two shapes we're dealing with. So to find the volume of a rectangular prism or a cube, it's always length times width times height. You just multiply all the dimensions. So we're told that the volumes of these two are equal. So that means the length times the width times the height of the rectangular prism is equal to the length times the width times the height of the cube. And the cube has the same length for all the dimensions. The length, the width, and the height, they're all the same, so we just write S. All right, so I'm going to make these, running out of room, so I'm going to make these smaller. All right, so now it says if the height and length of the rectangular prism are 8 feet and 4 feet, so the height is 4 feet and the length is 8 feet, whoops, actually it's the other way around, not that it really matters, but height is 8 and length is 4. And it says, so we know the volumes are equal, so we're setting the volumes equal to each other, and we know that the height and the length are 8 and 4. So we've used almost all the information. We've used this information, and we've used this information. So now we have to use the last piece of information. It says the side length of the cube is twice the width of the rectangular prism. So it's asking us what is the side length of the cube. So these are the possible answers. So this is going to be a plug-in problem. So these answers are S. S is going to be one of these answers. So let's say that S is 4. So we're going to plug in 4. Now it says here the side length of the cube is twice the width of the rectangle. So the side length, this is double the width. So the width has to be half of 4, which would be 2. So I know this seems like a very difficult problem, but I just want to demonstrate that even a problem that looks this difficult, you can solve with the plug-in method. So again, it says the side length of the cube is twice the width of the rectangle. So whatever the side length is, this is going to be half that size. So let's see if this equation works. 4 times 2 times 8 is 64, and 4 times 4 times 4 is 64. So that works. And you can do those calculations off to the side if you want to. So we got lucky on that problem because the first answer just happened to be the exact answer. All right, so I know that seemed like a difficult problem, and but again, if you just plug everything in, if you just write your equations, plug everything in, you can see it's really not that difficult to solve. Now if you're really intimidated by this problem, please don't be intimidated because I only gave you, I think, one homework problem that uses this type of thing. So you can always refer back to these problems. I want you to try number 12. Number 12 is going to be easier because we're doing area of a rectangle. So area of a rectangle or area of a square is just the length times the width. So go ahead and attempt number 12, and when you come back, we'll do it together. If you have trouble with that problem, don't worry. We're going to do it together. So pause the video, and when you come back, we'll see what we can do. All right, we're back. So the length of a rectangle is 3 times the side length of a square if the areas of the rectangle and square are equal and the width, blah, blah, blah. So the areas are equal. So the area of a rectangle is length times width. And the area of the square is also length times width, but the side lengths of the square are the same. And we can draw a picture if we want. It's always good to draw a picture. Whoops. And we have our square. Whoops, I meant to write length on that. All right, so the areas have to be equal. And what else do we know? We know the width of the rectangle is 3. And we know the length of the rectangle is 3 times the side length of a square. So far, we've used this information. And we use the width of the rectangle is 3 inches. So that's all the information we've used. Now we have to plug in a possible answer for S. So let's say S is 10. That's A. And it says the length, this is the last part of the information we need to use. The length of a rectangle is 3 times the side length of the square. So the side length is, we're going to say, is 10 because that's the first possible option. So if the side length is 10, that means the length has to be 3 times 10, which is 30. All right, so 30 times 3 is 90, and then 10 times 10 is 100, so that doesn't work. So it can't be A. So we have to go back, plug in 12 for B, 12 times 12, and then the length has to be 3 times 12, which is 36. And we multiply, and we get, let's see, 108, I believe, and 144. So that doesn't work. And you can do those computations off to the side if you want. All right, so now let's plug in 9. And L has to be 3 times 9, which is 27. That's the purple part. Whatever S is, L has to be 3 times the size. So then you get 3 times 27, or first of all, 9 times 9, that's one of our multiplication facts. We know that's 81. And 3 times 27 is 81, I believe. So there you go. Our answer has to be C. So we eliminated these possible answers. We eliminated these, and our answer must be C. So if you got C for 12, good job. If you have trouble with that problem, don't worry. That was a very difficult problem. The most important thing is to understand that we're using the plug-in method. We're plugging in 10, we're plugging in 12, we're plugging in 9, and we're trying to figure out the answer using the plug-in method. That's the most important thing. So if you had trouble with those, don't worry about it. It's not that important that you understand the exact problem. It's more important that you understand the overall plug-in method. All right, so let's try some more plug-in problems. Again, this is a very important tool when you're doing multiple choice tests, so we have to do a lot of these practice problems. All right, 13. When a number is divided by 6, the remainder is 4. What could be the number? So again, this is a plug-in problem. If you take a number which we don't know, and I'm going to call the number, I guess we can just call it n, and you divide it by 6, the remainder has to be 4. So we know that one of these has to be the answer. So we're going to try to plug in, I want to move this over because we don't have much room here. So we're going to try to plug in 89. And we're going to figure out what the remainder is. And here we have a remainder of 5. So it cannot be 89. So we're going to mark that one off. Now we're going to try 111. And we have a remainder of 3. So it cannot be 111. So now we try 66. It looks like that's going to go in exactly 11 times. Remainder 0. So it cannot be 166, or cannot be 66. Then I'm going to have to go to the margins here. 79 divided by 6. The remainder is 1, so it cannot be D. It has to be E. And you can test that yourself, but it's definitely going to be E. So again, that was another plug-in problem. So why don't you try one of these types of problems on number 14, and when you come back, we'll do it together. All right, we're back. When a number is divided by 3, the remainder is 1. So let's try 8. Plug in 8. Remainder is 2. That doesn't work. Let's try 9. The remainder is 0. That doesn't work. So we can mark that one off. And then we try 20. The remainder is 2. That doesn't work. So we can mark that one off. And let's try 28. That goes in 9 times. Remainder is 1. So that has to be the answer because the remainder is 1. So if you got D for that one, 28, good job. All right, so let's do some more plug-in problems. We have 2 more plug-in problems, I believe, or 2 types of 4 problems total, but 2 types of these problems. L is divisible by 6. It's also divisible by 3. Which of the following could be L? Now, we haven't talked about divisibility much. We're going to talk about that as we go along in this class. But divisibility means, if, for example, if 12 is divisible by 3, let's test if 12 is divisible by 3, and we'll test if it's divisible by 5. So 12 divided by 3 is 4, whereas 12 divided by 5 is 2 2/5. So 12 is divisible by 3 because we got a whole number. But 12 is not divisible by 5 because we got a mixed number. So if a number is divisible by another number, that means that the quotient is going to be a whole number. So that's what divisibility means. So we can try another one of those if you want. Let's try 24 divided by 6. That is, 24 is divisible by 6 because we get a whole number. And it just happened to be 4. 24 is not divisible by 15 because we get 1 and 9/15. So that's what divisibility means. So we're told that L, we don't know what L is, but we know it's divisible by 6 and it's also divisible by 3. So what we're going to do is we're going to take 45 and we're going to plug it in. We want it to be divisible by 6, and 6 does not go into 45, so we know that can't be our answer. So we can mark that one off. 28, let's see if that's divisible by 6, and it's not. 6 doesn't go into 28 perfectly, so we have to mark that one off. And 18 divided by 6, that goes in 3 times exactly. But we also have to test if it's divisible by 3, and that goes in 6 times. So 18 is divisible by 6, and it's divisible by 3. So that must be our answer. So I know that we're going through this kind of quickly, but again, the primary principle here is to learn the plug-in method. And as long as you're understanding the plug-in, that you can plug in the possible answers, that's the important thing. So why don't you try number 16, and when you come back, we'll do it together. All right, we're back. So let's try plugging in 7. 7 is divisible by 7, but it's not divisible by 4. Let's try plugging in 4. 4 is divisible by 4, but it's not divisible by 7. So it can't be those 2 answers. So I'll mark those off. And 14 is divisible by 7, but it's not divisible by 4, so we have to mark that answer off. 56 is divisible by 7, because 56 divided by 7 I know is 8. That's one of our multiplication facts. 56 divided by 4, that's not one of our multiplication facts, so we're going to have to use long division. And we can see it goes in exactly 14 times. The remainder is 0. Sorry, I'm getting a little cramped there. Move that up. Should probably do that. So 56 divided by 4. Whoops, sorry. remainder 0. So 56 is divisible by 4 and 7. So that has to be the answer. So if you got D, good job. All right, so we have one more plug-in problem. This is going to be another challenge problem. A student scored, and when I say challenge, I mean, again, with a lot of these plug-in problems, it seems that it's going to be impossible to solve the problem. But if you use the plug-in method, you can see that it's really not that difficult. So a student scored 88 and 85 on his first 2 math exams. What does he need to score on his next exam to raise his average score to 90? So if you try to compute his average score for the first 2 exams, you add up 88 and 85, and you get 173. Then you divide that by 2, and you get 86.5. So his average for the first 2 exams is 86.5. He wants to raise his average to 90 when he takes his third exam. So I know this seems really difficult, but here's what we do. We take, again, to find the average, you add up all the numbers and you divide by how many numbers there are. That's the definition of average. We learned that in the basics statistics class. It's also called mean. So we add up the first score and the second score and the third score, which we don't know, so we'll call n, and we divide by the number of numbers, and there's 1, 2, 3 numbers. So we divide by 3, and we want that expression, the average, to be equal to 90. So this is an algebra problem, but the problem is we don't know algebra, so we can't do this. But we can use the plug-in method. All right, so we're going to plug in 97, and that's going to take a while. You're not allowed a calculator, but I'm going to go ahead and use my calculator because these are big numbers. But if you did have to do this without a calculator, then that would be okay. You could just do the math on the side. So I added them up. I got 270, and then divide by 3, and you get 90. And we're in luck because it worked for the first problem. So A has to be the answer. So you can see it looked like it was impossible to do this problem, but I just plugged in the answer, and it turned out the first one was the correct answer. So that was not too bad. That was pretty easy. So for 17, we got A. So I know that that seems like a fairly challenging problem, but again, as long as you know the definition of average and you can use PEMDAS to solve this, it's really not that difficult. Now, notice that I wrote parentheses here. The definition of average is you add up all the numbers and you divide by the number of numbers, but you add up first. Okay, PEMDAS doesn't say to add up first. PEMDAS says to do division first. So that's why I had to write the parentheses, because I'm violating PEMDAS, or I'm violating the order of operations. So I had to use parentheses and then PEMDAS to write this problem out. So why don't you try 18, and when you're done, we'll do it together. Pause the video. All right, we're back. So we're going to add up 10 plus 5 plus 6 plus the fourth quiz score, which we don't know, and you're going to divide by the number of numbers. There's 1, 2, 3, 4 numbers. So we're going to divide by 4, and that has to be equal to, that has to be equal to 7.5. All right, so this is the plug-in method. Let's plug in 8 for n. 8 plus 6 is 14. 14 plus 5 is 19. 19 plus 10 is 29. And then we divide by 4. We're going to have to use long division for that. So that goes in 7 times. Remainder 1. Add a 0. 4 goes in 2 times. But we can see that it's 7.5. It's not 7.2 with other numbers here, so that can't be the answer. So that was kind of a shortcut there. We can mark that one out. Now let's try plugging in 10 to n. 10 plus 6 is 16. 16 plus 5 is 21. 21 plus 10 is 31. So again, we're using PEMDAS, where you're doing the parentheses first. Then we divide by 4. And we get, again, it's going to be 7, remainder 3. Bring down a 0. 7 again. So it's going to be 7.7 something something. So we don't want 7.7, we want 7.5. So it cannot be B. So mark that one out. Then we plug in 9. 9 plus 16 is 15. 15 plus 5 is 20. 20 plus 10 is 30. 30 divided by 4. 4 goes in 7 times again. Remainder 2. 4 goes in 5 times, and that's exact. So 7.5. So that's exactly what we want, 7.5. So again, this problem seemed like it was impossible to solve, but if we use the plug-in method, it's not quite so bad. So if you got C, good job. So that was a challenge problem. All right. So now we're going to go into precise definitions of math terms. When you're taking competitive tests, oftentimes they will require you to know the precise definitions of math terms, and if you don't know the precise definition, you can get the problem wrong. For example, we just went over divisibility, so we don't need to really go over that much right now. An example is an even number. Even numbers are numbers that are divisible by 2. But a lot of students are unaware that 0 is actually an even number. So that can get students into trouble if you don't realize that 0 is actually a number. Some people don't think that 0 is a number, but it's technically defined as a number. Also, 0, even though it's an even number, 0 is not a positive or a negative number. So if you're asked to list the first, for example, if you're asked to list the first 3 positive even numbers, if you list 3 as one of the first numbers, or excuse me, if you list 0 as one of the first numbers, because it is a number, then you're going to get that problem wrong, because 0, even though it's a number, and it is an even number, it's not a positive number. So the first 3 positive even numbers are 2, 4, and 6. So it's important to know the exact definitions of math terms. So what I want you to do is go ahead and take a screenshot of these, and we'll refer back to these as we go along. All right. So we're going to practice some problems that require you to know precise definitions. What is the average of the distinct prime factors of 28? So we've studied prime factors. For example, if you have something like 45, you want to factor it using a factor tree. But when you get to the point where you can't go any further, that's the prime factorization. Because all these numbers are prime. Prime numbers are numbers where you can't factor anymore. The only factors of a prime number are the number and 3, or the number and 1. So that's what it means to have a prime, to be a prime number. So prime numbers are 2, 3, 5, 7, 11, so on and so forth. Now 1 is not a prime number. So that's another example where you can get into trouble, because a lot of students will think that 1 is a prime number, but as you can see, 1 is not a prime number. 2 is the first prime number. Now, why is that? Well, I don't know. That's just what mathematicians have decided. So if you count 1 as a prime number, you could get a problem wrong on one of these tests where you're required to realize that 2 is the first prime number, not 1. All right, so now that we have a little review on prime numbers, and you can go back to the class on factoring to review that more if you want to. But we're going to go ahead and answer this problem. What is the average of the distinct prime factors of 28? So we have to find the prime factors of 28. That's 4 times 7. I know that because my math facts. And then 4 is 2 times 2. So now we have the prime factorization. These are all the prime factors of 28 because you can't go any further. But they want the distinct prime factors. Distinct means the numbers that are different from each other. So there are 3 prime factors, but only 2 of them are actually distinct. So we have to find the average of those 2 numbers. So to find the average, you add the numbers up and divide by the number of numbers. There are 2 numbers, 1, 2. So we divide by 2. So that would be 9 divided by 2. And that goes in 4.5 times. So 4.5 is the answer because that's the average of these 2 numbers. Sorry, it's a little sloppy there. But you can see that 4.5 is not one of the answers. So what we have to do is we have to go back to our division here. And when we get our remainder, we stop there. And remember, we learned in the a few more things class that we write the whole number 4. Then we bring the remainder up, and that goes in the numerator. And the divisor goes in our denominator. And 4 1/2 is the mixed number version of this answer. That's the same thing as 4.5. So our answer is D, 4.5. So again, we learned how to write a remainder in the mixed number form. All right, so why don't you try number 20, and when you come back, we'll do it together. All right, we're back. 22 is the product of 2 prime numbers because 2 and 11 are prime. 15 is the product of 2 prime numbers because 3 and 5 are prime. 10 is the product of 2 prime numbers because 2 and 5 are prime. But 27 is the product of a prime number 3 and a composite number 9 because 9 is not prime because you can keep going. So 27 is the answer. If you got 27, good job. All right, now we're going to go to multiples. We have to know what the definition of a multiple is. What is the average of the first 3 multiples of 8? So multiples of 8 would be 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. So these are multiples of 8. There's an infinite number of multiples, and the multiples are either the same size as the number or they're bigger. Whereas factors of 8 are either the same size or smaller. So factors of 8 would be, well, I'm going to do it the method we learned in class. So 1 times 8 and 2 times 4, and that's it. Those are the factors. Remember, we start on the outsides and then we move inwards. It's been a while since we did that. But the factors are smaller than the number 8, or they're the same size. So factors are very different from multiples. It's very common for students to confuse multiples and factors, so do not confuse those two when you're taking a competitive test. So now we have the multiples of 8, and it says what is the average of the first 3 multiples. So we can erase this one, and to find the average, we just add those numbers up, and we divide by how many numbers there are, which is 3. And 24 plus 16 is 40. 40 plus 8 is 48. So 48 divided by 3. We can use the long division algorithm for that. And we get 16. I don't have a lot of room here, so 16 must be the answer. So again, the purpose of these problems is to help you with the vocabulary. We learned what multiples are, and we learned what prime factors are, and we learned what factors are in general, and we learned the word distinct means different from each other. That's a term you're often going to hear on math exams. I know you probably already know that word, but it's especially important for math questions. All right, 22. What is the product of the first 2 multiples of 6? So why don't you try 22, and when you come back, we'll do it together. All right, the first 2 multiples of 6 are 6 and 12. So we want to know what the product is, so we multiply 6 and 12. We get 72. So if you got 72, good job. All right, 23. What is the sum of the factors of 16? So to write the factors of 16, we write 1 and 16 because 1 times 16 is 16. Then write 2 times 8 is 16, so those work. And then 4 times 4 works. So those are the factors. Again, this is a method we haven't learned in a long time, or we haven't gone over in a long time because we learned about factors in the beginning part of the course. But if you want to review that, go back to that class. So these are the factors of 16, and it wants to know what is the sum of those factors. So sum means add them all up. So if you add them all up, you get 31. So 31 is the answer. So why don't you try 24, and when you come back, we'll do it together. All right, we're back. So the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. Those should be all the factors. All right, so now what is the average? So we have to add them all up and divide by how many numbers there are, how many factors there are. So there's 1, 2, 3, 4, 5, 6. So add those up, you get 42. 42 divided by 6 is 7. So if you got 7D, good job. Now notice that we've been using the word average quite a bit. These competitive tests require you to know the definition of the average of certain numbers. You have to know average. Don't take a competitive test without knowing the definition of average. That's why we went over the definition of average and mean in the basic statistics course, or basic statistics class. 25. What is the product of the digits of 721? So again, look on your paper. Digits are the individual numbers that make up a bigger number. So we want to multiply all the digits, so we take 7, 2, and 1, and we multiply them. 7 times 2 is 14. 14 times 1 is 14. So the product is 14. So now you try 26, and when you come back, we'll do it together. All right, we're back. So we're going to find the sum, so that means add them all up. 3 plus 0 plus 2 plus 4, those are all the digits. And we get 9. So if you got 9, good job. All right, we're going to do 2 more of these that require math vocabulary, designed to teach you math vocabulary. The sum of 2 consecutive even integers is 110. Which of the following is one of these integers? So integer just means a whole number. Again, look on your sheet there, your screenshot. An integer is just a whole number. And if you didn't take a screenshot, you can do that now. So integer is just a whole number. And an even number is 0. The even numbers are 0, 2, 4, 6. They're all numbers divisible by 2. And consecutive means next to each other. So those are some examples of even numbers. So now let's find some examples of consecutive even integers. 6 and 8 would be consecutive because they're right next to each other. That's what consecutive means, right next to each other on a list. 2 and 4 would be consecutive. 10 and 12 would be consecutive, and so on and so forth. So that's what consecutive means. So this problem is actually a plug-in problem. Let's say that 38 is one of the numbers. If 38 is one of the numbers, then 40 will be the next number, because these are consecutive even numbers. They're next to each other on a list of even numbers, and they're both even. And so they want us to add those numbers, because it says the sum of 2 consecutive even integers is 110. So if we add these up, we get 78, so that can't work. Now 36 and 38, that works also, because those are consecutive. So if you add that up, you're not going to get a number big enough. So it cannot be 38. So we cross that one out. Now let's try 48. So if we use 48, we can use 50. Add those up, we get 98. We can also use 48 and 46, but we don't have a number big enough, so that's not going to work. So it can't be 48. Let's try 56. 56 and 58, let's try that. We get 114. So that can't be it, but let's try 56 and 54. Add those up, we get 110. So that's the answer, because we want 110. So 56 can be one of the possible answers. So 56 is one of the integers. And again, integer just means a whole number. All right, so why don't you try 28, and when you come back, we'll do it together. All right, we're back. Let's try 17. A consecutive odd number to that would be 19. So 19 times 17. We get 323. So it doesn't look like that's going to work. Now let's try 15 and 17, because those are also consecutive odd integers. So 15 times 17. And we get 255. So 17 doesn't work. Now let's try 7. 7 and 9 would be 63, and 7 and 5 would be 35. So that doesn't work, so we can get rid of that one. And let's see what else we can do. 13 and 15, let's try that one. We could also try 11 and 13, because they both have 13. So 13 times 15. And we get 195, so that must be the answer. 13 has to be one of the numbers. All right, so if you got 13, C, good job. So again, the purpose of those problems was just to help you with the math, the precise definitions of the math terms. Now again, what you have to be careful with is 0 is an even number, and 0 is also considered to be a whole number. 2 is considered to be a prime number. These are usually things that students will confuse. Most prime numbers are not even, but there is one number that is prime that is even, and that is 2. So these are just specific definitions that you have to know if you want to get all the problems right on competitive tests, or most of the problems. So be very careful about precise definitions. All right. So now we're going to do one more concept here. Again, we could spend years studying competitive tests, but we're just going over one more thing to know here. You're also going to be required to know basic units on competitive tests, or common unit conversions. So there are 12 inches in 1 foot. You're just going to be expected to know that. There's 3 feet in 1 yard, and 16 ounces in 1 pound, and 2,000 pounds in 1 ton. And there's 12 months in 1 year, and 365 days in 1 year. You're just going to be expected to know that. And you can take a screenshot of this. Let me erase these. So go ahead and take a screenshot of this. You're going to be expected to know that there's 7 days in 1 week. There's 24 hours in 1 day. There's 60 minutes in an hour, 60 seconds in 1 minute. And I also have the abbreviations here that you might encounter. 1 meter is 100 centimeters, and 1 meter is 1,000 millimeters. 1 kilometer is 1,000 meters. 1 gallon is 4 quarts, so on and so forth. 1 quart is 4 cups. And 1 dozen is 12. So if you buy 1 dozen donuts, that means you're buying 12 donuts. But if you say there were a dozen people at the meeting, that means there were 12 people at the meeting. So dozen just means 12. So again, you want to take a screenshot of those, and we're going to use those unit conversions in the following problems. So we have 6 more problems, and then we're going to be done for this class, and then you would need to do the homework. So 29, which inequality below is correct? Is 20 days less than 400 hours? Is that true? And remember, you could say that 400 hours is greater than 20 days in this statement, or you can say 20 days is less than 400 hours, but we never read right to left. We only read left to right. So the proper way to say this is 20 days is less than 400 hours. Because remember, the Pac-Man wants to eat the bigger number. So if he wants to eat the bigger number, that means 20 days is less than. So we read 20 days is less than 400 hours. So we need to figure out if that's actually true. So we in our conversions, we learn that in one day there's 24 hours. So what we have to do is, well, first of all, we can change both of these to days, or we can change both of them to hours. That's how we compare. But it's going to be more difficult to change 400 hours to days. So instead, let's just multiply 20 days times 24, because there's 24 hours in each day. So we're going to multiply there. And we get 480. So is 480 hours less than 400 hours? The answer is no. So that inequality is not true. We can mark that one out. So now we go to part B. 25 inches is less than 1 1/2 feet. So 1 foot, we can do this without an algorithm. 1 foot is 12 inches. 1/2 of a foot is 6 inches. So 12 plus 6 is 18 inches. So 25 inches is not less than 18 inches. So there's more than one way to do this. I just did that one in our head because we don't want this class to go on too long. So now that couldn't be the answer. What about 1,000 centimeters is less than 8 meters? Is that going to be true? Let me see here. Yeah, that's correct. 1,000 centimeters. So there's 100 centimeters in every meter. And again, we have to figure out what are we going to do? Are we going to convert this to meters, so they're both meters, or are we going to convert this to centimeters, so they're both centimeters? In order to compare, we have to have the same unit. I just chose to convert this to inches in the previous problem. I could have converted this to feet, but that would have been more difficult. If the conversion requires division, then it's usually more difficult. So I'm going to change this to centimeters so we can compare the two numbers. There's 100 centimeters in each meter, so we just do 8 times 100, which is 800. So 1,000 centimeters is not less than 800 centimeters. So it cannot be C. So now let's go to D. 48 donuts is greater than 12 dozen donuts. So 12 dozen, that means each dozen is 12. So if you have 12 dozen, that means 12 times 12, which ends up being 144. So 48 donuts is not greater than 144 donuts. So that cannot be the answer, which means that the last possibility must be the answer. So that would be part E. So that's an example of a conversion problem. We're using common unit conversions. So why don't you try number 30, and when you come back, we'll do it together. All right, we're back. So hopefully you used your screenshot, your unit conversions there. And if you don't want to use a screenshot because it's taking the file to some unknown location or something, then you can just go on the internet and find the unit conversions. Just type in unit conversions, and it'll give you a table. All right, so I'm going to change quarts to cups. That's going to be easier. So I multiply 2 times 4 because there's 4 cups in each quart. So 4 times 2 is 8. 7 is not greater than 8, so it's not going to be A. All right, so there's 1,000 meters in each kilometer, so 8 kilometers is going to be 8,000 meters. 8,000 meters is not less than 8,000 meters, so it's not going to be B. All right, now 5 pounds is less than 70 ounces. There's 16 ounces in each pound, so 16 times 5 is 80. 80 ounces is not less than 70 ounces. And I'm doing this in my head because we're running out of time. So 80 pounds is not less than 70 ounces. 3 tons. Now this is a problem that's going to require a little bit more math here. 3 tons, there's 2,000 pounds in each ton. So if we have 3 tons, we have 6,000 pounds. 3 times 2 is 6,000. So now we have 6,000 pounds, but we need to go to ounces. So you take 6,000 pounds and you multiply it by the number of ounces in each pound. So 16 ounces in each pound, so we multiply. And we get 96,000. So 100,000 ounces is less than 96,000 ounces. 100,000 ounces is less than 96,000 ounces. That's not correct. So our final answer has to be the correct answer. It just turned out that E was correct on both 29 and 30. All right. But if you wanted to figure that out, again, we don't really have time to do that, but you would convert days to hours. Then you'd convert hours to minutes and minutes to seconds. So that would take quite a while, actually. I just noticed that was a pretty difficult conversion, but we didn't need to do it because we know E must be the correct answer. So if you got E, good job. All right, 31, simplify the ratio 8 feet to 6 yards. Now, ratios are not supposed to have different units. So we cannot simplify the ratio because we have yards and feet. We have to change them both to yards, or we can change them both to feet. So if we change them both to yards, we're going to get fractions, so we don't want to do that. So let's change them both to feet. If you get fractions, go back and try a different method. All right, so we're going to have to convert, and we want to avoid fractions. So we're going to change yards to feet. So there are 3 yards in each foot. So 3 times 6 is 18. So we have 8 feet to 18 feet. Then they want us to simplify it. 8 to 18 is not one of our answers. So we have to reduce. Remember, ratios work just like fractions. You can use the fundamental principle of fractions. You can multiply both these numbers by the same number, or you can divide both these numbers by the same number. So let's divide both numbers by 2, and we get 4 to 9. And they write it as in fraction form. Remember, you can write a ratio in fraction form. You can write it with a colon, or you can write it with the word 2. So those are the 3 ways to write a ratio, and C is our answer. So why don't you try number 32, and when you come back, we'll do it together. All right, we're back. 10 quarts to 2 gallons. So there are 4 quarts in each gallon, so 4 times 2 is 8 quarts. So now the ratio becomes 10 quarts to 8 quarts. But that's not one of our answers because we have to simplify. So divide both those numbers by 2, and you get 5 to 4. So now our answer is written in colon form. We have 5 to 4. So if you got 5 to 4, good job. All right, so we have 2 more problems. If you've made it this far, I'm proud of you. Calculate 8 pounds 12 ounces divided by 1 pound 4 ounces. So in this particular problem, we're going to have to convert everything to ounces or everything to pounds. It's going to be easier to convert everything to ounces. So let's convert this pounds to ounces. So there are 16 ounces in each pound. So 16 times 8 is I'm going to go ahead and do that. 128. So then we do 128 plus 12 is 140. All right, so that's the first part of the problem. Now we convert 1 pound to ounces, and that's 16. So we add that to the 4, and we get 20 ounces. So everything is now in ounces. And I should write OZ for ounces. All right, so now the problem becomes 140 divided by 20. How many times does 20 go into 140? Well, you can do that as a long division problem if you want, but really it's just an estimation problem. 20 times 5 is 100, so it's got to be 7. So 7 is the answer. All right. Now the next problem is going to be somewhat different. You're not going to need to convert both of these units to gallons or both of the units to quarts. You can actually just calculate the answer because our answer has gallons and quarts. So go ahead and attempt 34, and when you come back, we'll do it together. All right, we're back. So what we can do is we can add the gallons first. 5 gallons plus 4 gallons is 9 gallons. Just waiting for my computer to catch up here. So 9 gallons. Then 2 quarts plus 3 quarts is 5 quarts. But the problem is there's 5 quarts is more than 1 gallon. Because 1 gallon is 4 quarts. So if we take 4 of these quarts and add it to the 9, that makes 10 gallons. And then we have 1 quart left over. So 10 gallons and 1 quart. So if you got D, good job. If you didn't get D, that's okay. Just figure out what you did wrong. So those are just some sample problems that you would need with the common unit conversions. So let's review really quickly what we did today. We learned the differences between competitive tests and in-class tests. We learned some examples of competitive tests, college entrance exams, high school entrance exams, and exams just to figure out what math course you should be placed in. We learned the different ways to figure out a multiple choice question, estimation, and shortcuts, and using the full algorithm. Remember, you have to figure out what the problem is testing you on. And we learned the powerful plug-in method that we can use with multiple choice tests. One of the answers has to be correct, so we can plug in the answers and figure out which makes the equation true. I'm sorry, this thing is jumping around like crazy for some reason. We also learned the precise definitions of math terms. I don't know why it keeps jumping around like that. I'm sorry. We learned the precise definitions of math terms. You have to know those definitions to, again, 2 is a prime number, 0 is an even number, but it's not a positive number, things like that. You need to know what consecutive numbers are. And we also learned the common unit conversion. So this was just an introduction to competitive tests. Also, they can be classified as multiple choice tests. But even if you don't take some of those competitive tests, you still may take some sort of a multiple choice test, and all these principles are going to apply to multiple choice tests. So if you take multiple choice tests or those competitive tests, this class is going to be extremely useful, this information. The way that you approach multiple choice tests is extremely different from the way that you approach other tests. You're going to be pressed for time. You're going to need to use all the techniques you can come up with to figure out the answers. And you don't want to waste any time going through those problems. And you do not need to show your work. You just get the answer as quickly as possible using all the shortcuts that you can possibly use. You don't use the long method or the longest method, the algorithm method, in each problem. So, this is the homework. You can get a screenshot of this if you want to take a screenshot of all pages, or if you want to get a screenshot of the first 2 pages. There they are. And the second 2 pages. And the last 2 pages. And you can see that we have the answers over here. Be sure to check all your answers. Now, you don't have to show your work on these problems because these are multiple choice problems. You need to get used to the idea of not having to show your work when you're doing multiple choice problems. So just check your answers and make sure you did all of them correct. So that's class 36. And I'll look forward to seeing you in class 37.